Hello and welcome back to the Brightflux Detailed Snowflake Core Certification Training Podcast Series. This is episode 22 and I am Yaqub Abdul Hakim, a certified Snowflake user. Today we will be diving deep into some of the core concepts that make Snowflake an incredibly efficient and flexible data warehousing solution, micro-partitions, and data clustering. Understanding these concepts is crucial for any Snowflake professional looking to optimize their data structures for both performance and cost. So let's get started. First, let's talk about what micro-partitions are in the context of Snowflake. Micro-partitions are an integral part of how Snowflake stores data. Essentially, they are automatically managed small units of storage, typically ranging from 50 MB to 500 MB in size. When you load data into Snowflake, it automatically breaks this data into these micro-partitions. This automatic partitioning serves several critical functions. It helps in managing storage efficiently, improving query performance by enabling fine-grained pruning of data during queries, and facilitating high levels of data compression. One of the fundamental benefits of micro-partitions is that they support Snowflake's unique architecture, specifically its separation of storage and compute resources. As a result, you can scale your compute resources up or down without impacting the underlying storage. This means your queries can run more efficiently as you can allocate compute resources based on the demand of your workloads without any reconfiguration of your data. Next, let's delve into data clustering. In Snowflake, data clustering refers to the arrangement or sorting of data within these micro-partitions based on the values of one or more keys. This sorting is crucial because it significantly enhances query performance by aligning data access patterns with the query's filter criteria. Imagine querying a table for a specific range of dates. If the data is clustered by the date, Snowflake can quickly locate and access the relevant micro-partitions, thereby speeding up the query process. It's important to note that while Snowflake automatically manages micro-partitions, data clustering requires a bit more effort. You must specify clustering keys when you create or alter a table, and although Snowflake provides some degree of automatic reclustering, in certain situations you might need to manage or trigger reclustering manually to maintain optimal performance. As we close this discussion, it's clear that both micro-partitions and data clustering are vital concepts in optimizing Snowflake's performance and cost efficiency. They are key to structuring your data in a manner that supports both flexible scaling and efficient access patterns. As you prepare for the Snowflake Core certification, understanding and applying these concepts will be invaluable. In the next episode, we'll be exploring another crucial aspect of Snowflake's architecture, so make sure to tune in. Thank you for joining me to explore these central themes in Snowflake's architecture. I hope this deeper dive helps solidify your understanding and aids in your certification journey. This has been Yaqub Abdul Hakim from Brightflux, wishing you success in your Snowflake endeavor. Until next time.